Adding like terms together. Negative 6i, negative 6i, negative 12i. And I squared once again shows up. So that's really negative 1. Take it further. 4 times negative 1, negative 4. So I can add those together now. 9 minus 4 is 5. Is it in standard form? Does the real part come first? Yes. Yes. There it goes. There's your answer. Good to go on multiplication. Before we head to division, I do want to show something that will help us figure out why we're doing what we're doing in division. It kind of comes back a little bit to multiplication. Can I erase this one? Remember back from factoring when you had a difference of squares, it would basically be the same thing, but your signs would be different in the middle, one would be positive and one would be negative. And what always happened to the middle terms? They cancel each other out. So let's think about imaginary numbers or complex numbers. I have 3 plus 2i and multiplying it times 3 minus 2i. Let's FOIL that out and see what happens. 3 times 3? 3 times negative 2i? Negative 6i. 2i times 3?
6.
Positive 6i. And then 2i times negative 2i?
Negative 4.
Negative 4i squared. What's going to happen to those 6 i's in the middle? They cancel out. Right, just like from a difference of squares, the middle terms cancel out. So I've got 9 minus 4, and I squared once again is just negative 1. So what's negative 4 times negative 1?
5.
Positive 4.
Yeah, that's what I meant.
And 9 plus 4 is
10.
13. All right. So that's kind of weird too, right? I'm taking a complex number times a complex number. My end result is a real number. And so once again, we can get real numbers using complex numbers. We're going to use that to our advantage here in division. So, let's get rid of that. When we go to division, let's say I have negative 10 over I. Well, why can't I leave it in that form? Right? You really can't do anything with it. Well, one, it's not in standard form, right? We don't have a real part plus an imaginary. Another thing is, remember that I represents the square root of negative 1. We have a radical in the bottom of a fraction. Right? From 0310, we had to get rid of it. We had to rationalize the denominator. So we have to do that again here. With imaginary numbers, the way you want to get rid of them is by using the conjugate. There's difference of squares from factoring. Well, difference of squares using complex numbers, they're called conjugates. They're not called difference of squares. Okay, don't get confused about conjugal visits or anything like that. We're talking conjugating, right? It's a totally different word. You might have heard it. A conjugate is like when we had 2 plus 3i, the conjugate, and it's spelled just like when we conjugate verbs in English, spelled the same way, conjugate. The conjugate is the same thing, but with the sign changed in the middle. Okay. We're going to use that when we do division. Here we just have a single term, so the conjugate of a positive I is just going to be a negative I. All we're doing is changing the sign on the I. So if I multiply across here, what do I end up on the top? What's negative 10 times negative I? Rule of signs still apply here. A negative times a negative is 10i. What's I times negative I?
Positive I. Negative I.
We thought the rules of our sign still apply here. Positive times a negative, negative, and then I times I.
Oh, there's a negative I.
I times negative I squared. Okay. Well, what is I squared? That's pop up in the last two problems. Remember, I squared is really -1. So don't forget about the negative sign out in front. Replace I squared with -1. So what's -1? What is that really? Positive 1. And then anything over 1 is itself. So my answer is just 10I. So our goal was to get rid of I in the denominator, did we? Yes. 10I. So we transformed -10 over I into 10I. What's really weird is they mean the exact same thing. If you go up to a higher level of math, I'll show you why, but they don't look the same, but they actually mean the exact same thing.
What?
-10 over I and 10I. So let's take it a little bit further. Let's make it a little bit more complex. Everybody good on this one? Let's say we have 7 plus, that's a typo, that should be 3I. 7 plus 3I over 2I. Well, what's the conjugate of a positive 2I? -2I. So we're just going to take the top and bottom by -2I. Just take the opposite sign of what's in front of I. I have more than one piece on the top, so I'm going to have to distribute. I'm going to have to take -2I times 7 and -2I times positive 3I. So let's work that. What's 7 times -2I?
14.
-14I. What's 3I times -2I?
-6I squared.
-6I squared, perfect. On the bottom, I've got 2I times -2I.
-4.
4I
Squared.
squared. Still got that I times the I. I can't add any like terms, but I can replace my I squareds with -1. So let's do that. -14I minus 6 times -1. I've also got an I squared on the bottom. So -4 times -1. So let's work that out. -14I. -6 times -1, that becomes +6, correct? And then I've got -4 times +1, or -4 times -1, sorry, that's +4. So we got rid of our I in the denominator, which was our goal, but we need to clean up our fraction a little bit. It looks a little bit odd. So first off, and I'm going to move over here now to keep this going. Is this in standard form? Does the real part come first? No. So let's rewrite it. 6 minus 14I on the top. And I've got 4 on the bottom. Well, in order to split it into a distinct real part and a distinct imaginary part, you have to put the 4 underneath both separately. Does everybody agree with that? It means the same thing, we just have to split up. We have to have a real part and an imaginary, they have to be divided. So does 6 over 4, does that reduce? 3 over 2, correct? Does 14 over 4, -14 over 4 reduce? Both even. 7 over 2, and then I. Looks a little bit different than what we've been dealing with, but I still have it in standard form. There's a real part, and then there's the imaginary part. It's in standard form. Okay. So our goal was to get rid of I. We did that to the bottom. We just had to clean up our fraction to make it into this standard form here, a plus bi. So we have one more. Perfect timing. We've got about 5 minutes. So let's erase that. I need some room here to take care of that. So on the top, I have 5 plus I over 2 minus 7i. We're interested in clearing I out of the bottom. So what is the conjugate of 2 minus 7i? Exactly, 2 plus 7i. Good job. I've got to take both top and bottom times that conjugate. Well, this looks like it's going to be a whole lot of foiling. I have 2 pieces times 2 pieces on the top. And 2 pieces times 2 pieces on the bottom. So if I FOIL the top, 5 times 2 is 10. 5 times 7i, 35i. I times 2, 2i. And then I times 7i, 7i squared. Let's move to the bottom. FOIL 2 times 2 is 4. 2 times 7i, positive 14i. Moving to the inner, negative 7i times 2, negative 14i. And then I've got negative 7i times a positive 7i.
Negative 49.
Negative 49.
I squared.
I squared. Right. A lot of pieces. Let's see if we can simplify a little bit. So on the top, I've got 10. I've got 35i plus 2i. That's 37i. And then I've also got 7i squared, which I can replace I squared with
Negative
1. Notice that I squared shows up a lot in our operations. So make sure that you're replacing that with negative 1 whenever you see it. On the bottom, I've got 4. What happens to the middle I pieces here?
Cancel out.
They cancel out, right? That's a good thing, right? You want to get rid of i's on the bottom. And then I've got negative 49 times I squared, which I'm going to replace with negative 1. So I'll take this step and move it over here. So I've got 10 plus 37i. 7 times negative 1 is negative 7. On the bottom, I've got 4. And that negative 49, right, times negative 1, we're going to add 49 now. So let's add some like terms here. 10 minus 7 is 3. 4 over 49, or 4 plus 49, is 53.
Why didn't you do it under each one like you told us the other one?
Because I'm not done with that with the problem yet. I'm getting there. We have to make sure it's in standard form. So we have to just have a distinctive real part and a distinctive imaginary. So I'm going to rewrite it as 3 over 53 plus 37 over 53 I. Can 3 over 53 reduce? The only way it could is if 3 goes into 53 evenly. It doesn't. Just like there's no common factors between 37 and 53. That's it. In standard form, they're reduced as far as it goes. All right? So that's some of the things you can do with imaginary numbers and all the operations. Like I said, once you get down to it, they follow the same rules as variables. They're real numbers, you're just adding together like terms. You just have to make sure that you're applying the definitions of imaginary numbers. All right, that's it. Please feel free to take some sandwiches and chips and drinks on your way out.
Okay.
And there's also an evaluation form, if you didn't have a chance to pick that up. Please fill that out, that gives you some good feedback on stuff that I might be able to do better next time, appreciate it. And hope to see you next one. Got one more left.
This one's
What is the next one?
final review, right?
We have